In this video, we'll be going over the recursive approach of minimum path sum. So given an m times n grid filled with non-negative numbers, find a path from the top left to the bottom right, which minimizes the sum of all numbers along its path. You can only move either down or right at any point in time. So for example, we have the grid, and then we're trying to find the minimum path sum. So we have 1, 3, 1, 1, 1, which is the minimum path we can make by only going rightward and downward, which has a sum of 7. So let's go over the thought process. We will first implement a recursive approach. We will need to keep track of our current cell at RC, the row and the column. Then in each of the recursive call, we have two choices. We can either go rightward or go downward. We will need to pick the choice that will give us the minimum path sum. Now let's go over to pseudocode. So we're going to implement the recursive approach. Now we're going to ask ourselves, what parameters do we need? We need the current row, the current column, and the input grid. Now what's the base case? The base case is when RC is at the bottom right corner, then we only have one choice left. That means we cannot go any more directions. So the only sum we can get is the value at the cell. So we're going to return grid RC. Then in each of the recursive call, we're going to create a variable min sum to keep track of the minimum sum. This will initially be integer.max value. It's just a very large number to keep track of our minimum sum as we update it when we go rightward or we go downward. Then we'll first recursively, before that, we're going to check if R is not at the last row. This means we can still go downward. So we recursively find the sum. Find the sum if we move downward. The minimum sum if we move downward. So we're going to increment row by 1. Then we're going to update min sum if sum 1 plus the value at the current cell is smaller. Then if C is not at the last row, last column, recursively find the sum 2 if we move rightward. Now we move rightward is column incremented by 1. Then we're going to update min sum if sum 2 plus grid RC, the value of the current cell is smaller. Then we can return the minimum sum. Now let's go over the time and space complexity. The time complexity is O of 2 to the n plus n, where mn are the number of rows and columns. This is because each recursive call has two choices with a depth of n plus n. The depth is n plus n because we're only allowed to go rightward and downward. So now with the space complexity, we need to account for the recursive call stack memory, which is n plus n. Now let's go over the code. So we're going to implement our recursive approach. We'll initially start from the top right corner. So it's going to be at the cell 0, 0. Now we want to check the base case. If we have reached the bottom right corner, that means we cannot move anymore. So we only have the value at the current cell. So if R is equal to grid.length minus 1 at the last row, and C is equal to grid R.length minus 1 at the last column, then we can just return the value at the cell. Now we're going to create a variable min sum to keep track of the minimum sum. Then we want to check if R is not equal to the last row. So if R is not equal to grid.length minus 1, that means we can still go downward to the next row. So I'm going to update minimum sum if the sum of going downward is smaller. So we want to recursively move downward. So r plus 1, c, and grid plus the value at the current cell. Now if c is not equal to grid r down length minus 1, that means c is not at the last column, which means we can move rightward. So I'm going to update the minimum sum. If the minimum sum of moving rightward is smaller, then we can return min sum. Oh, it's math.min. Alright, we've got our TOE error. So this solution is not efficient enough due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization, which will be the next video. We will be optimizing our recursive approach using memorization by caching previously calculated results. Let me know if any questions in the comment section below.